Assalamu alaikum, Ali.
जी वालेकुम सलाम।
Sorry, really sorry, Ali, for the delay. I got some problem actually, and I was trying to figure it out. And today I'm trying to do some questions on forces. Can you update me what what is the status? How much work you have done? The topic is forces, and this is the chapter which contains forces, pressure, upthrust, and a very important topic, moment. Now, define pressure. What is the unit of pressure? Oh, sorry, definition of pressure. Pressure is the?
Force per unit area.
Yes. Use the kinetic model to explain the pressure exerted by a gas. Gas molecules randomly collide with each other, and they also collide with the container wall. This is a gas molecule. It rebounds also, and it experiences an impulse. Now, impulse upon time gives you force, and force gives you pressure. I have made a sequence, and this is according to our new syllabus, even though this is an old paper, but you always have to connect impulse to force and force to pressure. If you want to remind this important concept, you can copy it back. And if you are copying anything, remember to copy the year number. June 13, 21, 4. Explain whether the collisions between the molecules of an ideal gas, is a terminology from chemistry, are elastic or inelastic. So can you remind for me that the collisions of gas molecules, are they elastic or inelastic? I have shown same velocity v.
In ideal gas, they're elastic.
Very good. And he says, explain. You will say that the collisions do not cause any loss of kinetic energy. So collision is elastic. Brownian motion is not required anymore. It was in our course. And do you remember this topic if you have studied this topic in O level, Brownian motion?
No, I don't remember this one.
It was a topic in which there was a smoke box. Just remind, I think you can remember it. It was a smoke box. A microscope and a bright source of light. No need to copy it. like this. This is called Brownian motion experiment. This guy actually had shown that smoke particles, carbon particles are moving randomly when they are viewed from a strong microscope. And what he says here, describe the observation made using the apparatus. Smoke particles were moving randomly. Two conclusion about the properties of molecules of a gas that follow the observation, because syllabus was changed in 2016 and then in 2022, and before it was changed in 2007. So this is one of an example that syllabus changes actually got some questions in trouble. So that conclusion about the properties, molecules are always in a state of motion and they move randomly, not in any particular direction. Now, define the torque of a couple. Do you remember the definition of torque of a couple?
Force into displacement in the direction of the pivot.
But do you remember there is no pivot in torque in the definition of torque? What is torque? Torque of a couple. Remember the word couple means how many forces to consider?
Two forces.
Yes, and torque is the turning effect. Torque of a couple is actually the turning effect of two forces, and it's a pure turning effect. There is a separation between them, D. This is the formula. So torque of a couple is the product of a force and the separation between two forces. Can you repeat for me? Torque of a couple is the product of a force, one force, product of a force and perpendicular separation between two forces.
It is the product of a force and the perpendicular distance between the
Yes,
two.
it is the product of a force and perpendicular separation between the two forces. Do not mention pivot in the definition of torque. There is a difference between the definition of torque and the definition of moment. A wheel is supported by a pin and its center of gravity is shown. The plane of the wheel is vertical. The wheel has radius 25. The two parallel forces, each of 35 Newton, act on the edge of the wheel in the vertical direction shown. Friction between the pin and the wheel is negligible. List two other forces that act on the wheel. State the direction of these forces and where they act. The other two forces, it's a wheel is vertical. And he says friction between the pin and the wheel is negligible. So friction I'm not considering. Do you think we should consider the weight of the wheel?
Yes, downwards.
But what about the second force?
The normal reaction force.
I'm also thinking on that. Two parallel forces act on the edge of the wheel in the vertical direction. One force is the weight. Weight is acting downward. So second, do you suggest One is a possible normal reaction. What do you guess?
Like I can only think of the normal reaction right now.
Friction, because friction was a good option. Friction was a very good option, but he himself have negated it. So let's keep that. So we can show, he's asking to show on the diagram or just write. So weight is downward. Calculate the torque of the couple acting on the wheel. I had already given the formula upside. You can check it. But remember, you have to take the whole separation. So if I take it in whole, now this is the formula for torque. Can you get the answer for me?
It's 17.5.
17.5. Should I round it? Because it's 17.5 is not a bad answer. I think we can keep it. Otherwise, we can put 18. The data in the question, all data is 2 sig fig. Now, the resultant force on the wheel is 0. Explain by reference to the 4 forces acting on the wheel how it is possible that the resultant force is 0. You will tell the examiner that, look, W and R are equal. The wheel is not moving up and down, and the wheel is rotating. 35 Newton force, 35 Newton the forces are equal and opposite. He's giving 1 mark, so I think that will be fine. State and explain whether the wheel is in equilibrium. Do you remember there are 2 conditions of equilibrium in that chapter?
Resultant force should be 0.
And what was the second condition?
No acceleration, constant velocity.
No. Resultant moment is equal to 0. Do you have notes? Because I didn't do this chapter with you. There are two conditions.
We haven't done this chapter. I don't think so. I don't have them in my copy.
No, definitely you're right. We haven't done it with together here, but actually we did all the main chapters and we started because I feel that you need some revision in this chapter. Because there are two conditions: resultant force is equal to 0, resultant moment is equal to 0. So you can write it with me, and let's see if we need it. We can put a revision class for this chapter, because that chapter doesn't come every year, but obviously it's a main chapter. Now, number 8. Acha, now he says state and explain whether the wheel is in equilibrium. It is fine, but this is not fulfilled. It is that chapter which contains another tricky topic, which is called upthrust. Now, a uniform plank AB of length 5 meter and weight 200 Newton is placed across a stream as shown. A man of weight 880 Newton stands a distance x from end A. The ground exerts a vertical force on the plank at end A and a vertical force FB on the plank at end B. As the man moves along the plank is always in equilibrium. Okay. And you have just studied with me, there are two conditions of equilibrium in this chapter. Explain why the sum of forces FA and FB is constant no matter where the man stands on the plank. This is a bit tricky question, but you have to see carefully that the system is in equilibrium, right? Now, if the system is in equilibrium, be careful, and I'm writing the first thing for this diagram. If system is in equilibrium, the total upward force should be equal to total downward force. Am I right?
For equilibrium.
Yes. See this equation, FA plus FB is equal to 1080 Newton. Total upward is equal to total downward. Now, this total is constant. Now, can you answer this question now? Explain why the sum of the forces where the man stand, because it doesn't matter where the man stand, the total downward will remain 1080. So you will tell the examiner that look, total look, this one. You will convince the examiner by this approach, and I have shown a calculation here. This is also required. I hope you are solving the new papers on your book on the printed form, because actually this is the most effective thing. Many people are doing this mistake in this month because now pressure is there. a lot of pressure is actually there. So people are just going through the paper and they are not writing, just like when you see I'm working there. So I haven't done, I'm not doing it first time, obviously, but I always write because this is the way you get the habit of controlling your answer and making it in a script form. So it's very important that every student should do the work in writing. If you have the latest paper, and doesn't matter you have or not, you should print it, or at least if you are solving it, use a gadget in which a full space is given. Man stands at distance x is equal to 0.5 from end A and use the principle of movement. What is the principle of movement?
That about the clockwise and anti-clockwise.
Sorry, I missed it.
The clockwise moment will be equal to the sum of the
Yes.
anti-clockwise.
Total clockwise moment now that, do you remember that in A level, it is common that there is no pivot given? In many questions, like in O level, pivot was always given. Now, this is a tricky part. This is a tricky part that many times they do not give pivot. Now, what should I do?
Take the center of gravity as the pivot.
You're right, very good. And but I tell you a very interesting thing. If you take the center of gravity, you will have two unknowns. Can you tell me what are the two unknowns? Shabash.
The distance and the force.
No. The two unknowns. Look, these are the two unknowns now. If I take, this is the center of gravity. If I take the pivot here, I cannot solve because how many unknowns are there?
The FA and the FB.
Yes. Now, if there are two unknowns, it's a mathematical rule that if there are two unknowns, you can't solve the equation. So I tell you a very interesting technique, a very smart technique for A level, that it's not necessary to take pivot at the center of gravity. A level physics says that you can take pivot anywhere. I repeat, you can take pivot anywhere on the sheet. And whenever you take pivot at a point, the force on the pivot will be cancelled out. So if I take pivot at CG, 200 Newton will be null. Okay, you got the point? Now, what I do, I know there are two unknowns and I can take pivot anywhere. So what I take, I suppose a pivot on which position? A. What's the benefit of taking pivot at A? When I take pivot at A, FA will be cancelled. Physics says that a force cannot create a moment. A force cannot create a moment if it is acting at the pivot. So I
we will take the 200. So the 200 Newton of the center of gravity will be taken in this part.
Yes. Now, if I shift the pivot at A, now the main, now use the principal moment to calculate the magnitude of FB. Read the question again, and now let me know where I'm, why I'm taking pivot at A.
To cancel out one variable.
Yes.
The FA.
And FA will be cancelled, and actually what you need to find.
FB will be left then to find.
Yes. And now read the question again. Why I am allowing FB to survive?
Because we need to find FB.
Now you got them. This is where, Ali, this is where AS physics is superseding. That is where it is so much challenging, because you have to read the question at least 2 times before you start. Otherwise, the examiner can easily trap you, because so many things like any student can take with anywhere. That's a simple rule. But here you have to put it like this. Now, what should I do? And he has given me the value of X also. Now, can you help me writing the equation 800 and the distance is X, 880 and distance is X. I'm taking clockwise. This is clockwise. This is clockwise. And this is anti-clockwise. So help me in writing the equation. Should I say 880 into X?
880 into 0.5. Yes.
Yes, very good. 0.5 plus, should I say 200 into 2.5?
Not 5, 200 into 5, 2.5.
Yes, 200 into 2.5. FB into can you help me solve this equation? I need to find FB.
It is coming as 188.
Should I leave it like that and I should make it 190?
190.
Good. The variation with distance x of force A is shown, force against distance, on the axis of figure 3.2. Sketch a graph to show the variation with x of force FB. This is sketches are always tricky. He is making the sketch. He has made the sketch for f of A and asking you to make a sketch for FB. Read the question carefully.
So will this be like an F is equal to Kx graph, the Hooke's law?
No. You have to go back to the diagram again and you have to see what he is saying. Now, can you tell me if I'm saying I'm increasing X, so where this boy is going? If X is increasing.
So he's going towards B.
Now you got it. So it's going like this. When it's going like this, the sketch shows FA is decreasing. FA should decrease because it's going away now. His weight. If you have ever crossed this type of wooden plank, when there is a small trench, it's very common in our Pakistan that people put a wooden plank which sags, and it's not a proper bridge, it's like sagging plank. And if you move, you feel the sagging shifts with you. So when this man is moving towards the position B, do you think that the shifting of force will also occur?
Yes.
FA will decrease. And what will happen to FB?
It will increase.
Very good. FB will, because the load shift towards B. So now the position is clear. You have to draw this sketch in this way that FA decreases and FA decreases and FB increases. Sorry, is this? Now, any idea how I made this blue line?
The original force was not 0.
Yes. So FA decreases and FB corresponding increases. So the total cannot change. We already had mentioned that the total force has to remain how much?
1080.
Yes. So the total will remain the total will remain the same. So I have to keep this number same. So I will move the blue line exactly opposite to FA. Define pressure. Pressure is the force per unit area. This is November 14. A cylinder is placed on a horizontal surface as shown. The following measurements were made on the cylinder. Do you know it is a case of uncertainty now? See this data.
Due to the plus minus.
This is the symptom. This is the plus minus, which is showing us that this is a case the following measurements were made on the cylinder. Mass is given, diameter is given. Now, I know the formula of pressure. So he says calculate the pressure and calculate the uncertainty. Let's start with pressure, or better starts with area first. Area is pi d square upon 4. Diameter is in centimeter, but he wants in Pascal. So diameter is 9.4 centimeter to meter. I hope you are copying with me. So that will be a practice, and you are copying. You can copy all. You should always see the November year number. And that will be a good practice if you write the whole working. Calculation is not a problem actually. Pressure is equal to, oh, how we get the force? Should we take
The
it as
weight.
weight? Sorry, a hanging problem. Did you get the area?
Yes, I'm using 6.9. And the final answer is coming as 7200 Pascal.
How much was the area?
6.94 into 10 power minus 3.
Calculate the actual uncertainty in the pressure. Now, pressure is equal to weight upon area. When you write a formula for uncertainty, do you consider the constants or you ignore them?
Ignore them.
Good. So I have made this formula. I have ignored all the other constants. I'm using this symbol, delta P upon P. Do you remember why the 2 is sitting outside
Due
separate?
to the square.
Very good. So it means you remember this. That's very good. He says actual uncertainty. So I will take pressure on left side. This is called rearrangement. Many people do not actually give time to this. They always focus on putting the numbers and solve it, while examiners do not get impressed by a calculator work that actually can do anyone. I'm getting the same problem, sorry. Um, Let me know once you get an answer.
I'm getting 167.
167. It's a big number. Maybe it's right. Okay. Uncertainty is always given correct to one significant figure. It's a very important requirement. Uncertainty is always given correct to one sig fig. So I'm writing it as 200. So how I write the final answer? I will say 7,200. Did you get this point? 167 correct to 200. Why we have used so much excess rounding?
For one significant figure.
Yes, uncertainty is always given. Uncertainty is always given correct to one significant figure. This chapter is looking fine to me for moment. This chapter is looking fine.